Okay, so going over the quiz questions. The first question is, this is the question right here, all right? You're given all this information, all right? And the first question is calculate delta S. So almost everybody got this right that did it, all right? There was only one person that didn't get it right. So I want to address a few things, all right? Here are the few things. The units for a delta S, to be clear, are joules per Kelvin. So I think, Andrew, your units were kilojoules. Yeah, so that's not gonna, that'll get a wrong point. I think I didn't give you the point for that. So to be clear, joules per kilojoule. So look right up here, they're going to be, the delta H might be given to you in kilojoules, but your absolute entropy has to be given to you in joules. You're gonna be given joules per kilojoules per mole, and then your answer is joules per kilojoules per mole. You even, because this is mole of reaction, so you even could get just joules per Kelvin, sorry, per Kelvin, not kilojoules. You even could just be given joules per Kelvin for S. But it's gotta be joules. I mean, ultimately, you can convert it, but it's going to be given to you in joules. The standard is joules. All right? For all of you, your units sucked. They've got to get better. All of you, your units have to get better.
Wait, so the answer was -146 joules per. Okay, because you marked it wrong on mine, and that's what I put.
Negative 147?
Yeah. And I was very concerned because I was like, okay, this was the one I actually knew how to do. So
All right, so I'll go back and look.
Oh, okay.
All right, now that.
If I know that it's right, it's fine. I just was concerned.
Well, it's not fine because you get a score. You want the point.
It's accuracy?
Yeah, it's accuracy.
We didn't know about the other video. It would have been better if we knew about it.
Okay, so we'll talk. The other thing is that needs to be you have to show your work. It even said justify. It said show your work. I think it even says in the problem, right? It does say that in the problem, right? Am I right? It says show your work in the problem. Is that correct? For A, does it? So calculate. Yeah. So you have to show your work. You have to show your work in everything. I understand you're typing it in, so you're welcome to just like type in numbers, you know what I mean, so I can see what you're doing. But you've got to start, you have to start showing your work for everything. Okay? I understand that it's me, so it doesn't have to be for everything, but you have to show your work and your units for everything. Remember, if they don't know that you know, they don't know that you know. You must show everything, okay? Which means what I would have written down here for that, this is their answer, but because I wanted to make sure I had everything I needed to show you how to do it, I would have written this. Delta S is 2 times 240 minus this times this, and then I would have calculated. So this is final minus initial. Products, moles times this, moles times this. Okay? So this is like N times the entropy. And remember, this here, this and this was looked up in a chart. So this was looked up in a chart for NO2. What is the entropy of NO2? And they looked it up. So you're going to take, I have 2 moles of nitrogen monoxide, 2 moles of nitrogen monoxide, minus 2 moles of nitrogen dioxide, plus 1 mole of oxygen. And I subtracted my reactants from my products. Remember, this is how we did bond enthalpy too, because we're going to do a bond enthalpy also, right, in review. Bond enthalpy, we did the products, sorry, not bond enthalpy. Never mind, pretend I didn't say that. all right? So this is how we do delta H, this is how we do delta G, this is how we do delta S, all of these things. We're going to do how many moles times the energy or whatever it is minus how many moles times the entropy or enthalpy in the reactants, okay? All right, next. Determine whether the reaction is thermodynamically favorable. So what you're determining is what delta G is. From this reaction, you have delta S. They gave you delta H, and it's at 298. They told you that. So you're going to use the delta G, all right? But you're going to calculate the delta G. So you're going to plug in 112 kilojoules minus the 298 times 0.147 kilojoules. You can do it either way you want, and you can get it in terms of joules, but you better round off to 2 or 3 digits. You only get plus 1 or 2. You better use your significant figures. Some of you had like 68,453. Did you forget about sig figs? I don't know what happened to you. All right? And you better make sure that your sign is correct, because the whole point of this is if delta G is negative, it is thermodynamically favorable. If delta G is spontaneous, it's exothermic. That is good. Exothermic is good. It means there's extra energy being put out into the world. That's good. If it's endothermic, it means that the reaction needs for energy to be put into it. That's bad. That reaction's not going to go unless you put it on a burner. Okay? Is this helping? All right, so you would need to show this setup. You don't have to show your calculation, but this, you need to show negative 12 kilojoules per mole minus 298, you don't have to show the Kelvin, but times negative 0.147 kilojoules per mole. Questions? Okay, and then you're going to need to answer the question. The question is, what is delta G? Write it out. Delta G prime equals negative 68 kilojoules per mole with the units. Then the question is it thermodynamically favored? Yes, and justify it. It is thermodynamically favored because delta G is negative. If you don't write delta G as negative, then I'm going to ask you, well, maybe it's because the units are kilojoule per mole. How do I know that you know that it's because it's delta G is negative? See? That's why, right? Maybe it's because delta G is less than 1,000. See? You have to tell them, why is it thermodynamically favored? Okay? All right, next. This was the big problem. And this was the one that we had gone over. So, you're going to use this equation. A few of you got that. A few of you chose not to use any equation. No, do not do that. Do not use no equation, because how do you know that the 1 point wouldn't be for using this equation? Write down how you do the problem. You don't know where the point is. Delta G is negative. How do we know that? Last problem. So here's what you're going to do. Negative. Okay? This is negative, which means negative. Okay. So ln of k, must be positive. Okay? All right. If ln of k, this is me. If ln of k is greater than 0, ln of k is greater of 0 when k is greater than 1. Now, I thought maybe I got my notes mixed up. So I went back and I looked. I did not. Those are the notes you have. ln of k is greater than 0 when k is greater than 1. Oh my God, Miss Paxton, I'm on this test and I'm working and I'm so confused. What do? I can't remember. Is ln of k greater than 0 when k is greater than 1 or when k is less than 1? I can't remember. What do? Try it. Where's ln? I have this stupid calculator. I'm confused. I don't remember. What do? ln of 2, which is greater than 1. Oh, it's positive. When ln is greater than 1, ln is positive. What if ln's less than 1? ln of 0.2. Oh, it's negative. When ln is less than 2, it's negative. I better write that down so I don't forget and then try it again just to be clear. Do you understand what I'm doing? I'm trying it out on the test because I can't remember. So I'm trying it out. And then I'm going to go and I'm going to say G is negative, this is negative, this must be positive. So that means that ln must be greater than 1 so that ln of k, I'm going to try it out one more time. What if ln was 5? Would it be, try it out again. Do you understand what I'm doing? Who cares if you know it? Fix it. Make it right. Do you understand? Make it right. Okay? Plug something in. You know the temperature's 298. Well, you don't know this is 0.0821, so you're right. Do you understand? All right. Does that help? Okay. Your homework tonight. 53 and 45, page 931, not 65. 53 and 45. Wait a minute. Yeah, 53 and 45. Okay? Okay. Get her done. Okay, Nico, I'll give you that point if you have negative 157. I'm going to check homework tomorrow. Yeah. So I was very confused. I was very confused. K for the reaction is greater than 1. Okay, so I'll give you one more point also. For some reason, I was like staring at yours and staring at yours and staring at yours, and I was like, how could she have missed this point? And I must have been like spacing out or something, which is really scary when you think that they're doing, 5,000 of them, right?
Yeah.
Okay, Anna, and Nico. Okay, gotcha. All right.
I'm just a little worried about that test grade because if I knew about the video, I really would have watched it. Like I watched all the stuff.
No, the same thing happened to me. Like I didn't
know it was there. Like I don't know. I don't.
How could you not have known it was there?
I didn't know. When did you post it? Because I do my stuff like in school. Usually I don't do it after school. I don't know if you post it in the morning. Obviously.
No, I
that's not
posted it the night before.
Before? Yeah, I don't know how
Yes.
we missed it.
I went to grab a post-it off the thing and it's in the video.
I think why I missed it was because you had assigned like the things as due as 11:59, so they showed up in my to-do list. So I'm like, that's what she posted, and I clicked on those, and I assumed that you would put everything in the one thing that